All right, in this example, we're given the following information. A function's second derivative, f double prime, is equal to 2x. And we're told that when we evaluate its first derivative at 4, we get the value 11. And when we evaluate the original function, no derivative, at 3, we get 0. Given this information, we're asked to find f of x, the original function. Okay? So we're given f double prime. Well, to go backwards, to undo a derivative, to get the antiderivative, we take the integral. So we're going to do the integral of f double prime, and that's going to give us f single prime. So the integral of 2x with respect to x is going to be equal to 2x squared over 2 plus some constant, and I'll call that c1. I'll go ahead and reduce this, so I just get x squared plus c1. Well, if I were to do the derivative again, I'm also going to wind up having an x on this constant, which we can do. I'll go ahead and do it just to show what happens. So let's do the integral of f single prime. That's going to give us regular old f of x like we're looking for. And so that's the integral of x squared plus c1 dx. Well, if I take this integral, this is going to become x to the third over 3. I've got plus some constant, so that's going to become c1 times x. Remember, if you take the derivative, the x would go away. You still have that c1. And now, after taking the integral of the inside, we have to add on some other constant. Call it c2. Okay, so this is f single prime. This is just f of x. But this would not be our final answer because we don't know what c1 and c2 are. We need to find those before we can say we found f of x. If I gave you some number to plug into here, if you don't know what c1 and c2 are, you're not going to be able to give me the result except in terms of c1 and c2. But we're told that when I evaluate f prime at 4, I get 11, and that when I evaluate regular f at 3, I get 0. I'm going to use the f prime first because he only has one constant. So f prime of 4, I'm plugging in 4 here. So that would be 4 squared plus constant number 1. So that's equal to 16 plus constant number 1. And we know that this is supposed to come out to equal 11. So that equals 11. Now to solve for c1, I'm just going to subtract 16 from both sides. And so I get c1 is equal to 11 minus 16, which is negative 5. And so now that I have what c1 is, I can rewrite my regular f of x with one of the constants there. So x cubed over 3. c1 is negative 5, so minus 5x plus c2, which we still don't know. But again, we're told the original function, when I plug in 3, gives me 0. So let's plug that in. F of 3 is equal to 3 cubed over 3 minus 5 times 3 plus c2. Well, 3 cubed over 3, that's 27 divided by 3, which is 9. So we have 9. And then minus 15 plus c2. And we already know that this is supposed to equal 0. So equals 0. So what I can do is combine these numbers. So 9 minus 15, that's going to give me a negative 6 plus c2 equals 0. Now if I add 6 to both sides, I get that c2 is equal to 6. So now I can finally rewrite my original function. I'll do it right here. F of x is equal to 1/3 x cubed minus 5x plus 6. And that would be the final answer. So just as a recap, we're given the second derivative. So to get our original function, we're going to have to integrate twice. But when we do that, we wind up with two constants that we don't know. But we're given that f prime evaluated at some number equals 11, that number being 4. And so we can solve for the first constant using this information. And so we get that constant. And now that we know that constant, when we take the integral again, we only have one constant we don't know, c2. And so I can use this information to find out what that constant is. And so we do that, and then our final result is the whole function with those constants plugged in. And so the answer would be 1/3 x cubed minus 5x plus 6, and that is this example.